Hello and welcome to another math-tastic video here in Mathland. Okay, so today we're going over radicals in the denominator. Okay, for those of us who live in Mathland, we don't care for the radicals in the denominator. So if we see one, we need to get rid of it. We need to figure out how to get this radical out of the denominator. And we made up a special word for this. It's called rationalization. We need to rationalize this fraction. We need to eliminate this radical from the denominator, so we rationalize, which means we need to multiply this radical by something that would remove the radical. So if we take a radical, like say square root of 2 times itself, we would get square root of 2 times square root of 2. That would be the square root of 4, right? Which would be just 2. Okay, so using this principle, if we multiply a radical times itself, we end up with, check it out, just the radicand. It's the same number. So even if you multiplied it out, 2 times 2 is 4, square root of 4 is 2, we still get the same thing. So, shortcut way of thinking about it, if you multiply a radical times itself, you end up with the radicand, what's left inside the radical. Okay, so let's apply that over here. So if we need to get rid of this radical, hey, look, we got rid of the radical here. We multiply by itself. So square root of 3 times the square root of 3, I know I'll end up with just 3. But whatever we do to the denominator, we have to do the same thing to the numerator. So we're going to multiply the square root of 3 over the square root of 3. Okay, and in doing it, like we did over here, in doing this, we need to multiply the numerators. So we have 3 times the square root of 3. All right, it is what it is. In the denominator, if I have a radical times itself, I'm left with just the radicand. Because if you think about it, square root of 3 times square root of 3, that's the square root of 9. Okay, which is 3. Okay, so here we go. I've got 3 square root of 3 over 3. Now, I don't think I'm done yet because I see some simplification that can happen. Don't you? Yes, you do. Okay, so let's simplify this. I have the radical in the numerator, which is fine. As long as it's not in the denominator, I'm okay with this. And so are many people in Mathland. But I do need to simplify this because you always want to simplify your fractions. So 3 cancels out with 3, and I'm left with just the square root of 3. That's it. Ta-da! Yay, radicals in the denominator. No more. Okay, so another thing we need to do when we are dealing with radicals in the denominator, if we have one term that's a radical, we rationalize. Now, if we have multiple terms, let's say 4 over 1 minus the square root of 2. Okay, I need to get rid of this radical in the denominator, but now it's not by itself anymore. When it's by itself, we rationalize. That's what we call it. Multiply the top and the bottom by itself to get it out of there. But now we have a non-radical number and a radical number. We have a binomial in the denominator. So now this is special, and we have a special name, just like we had rationalized for there. We're going to use the binomial conjugate. Okay, so this is a binomial. It has 2 terms. It's in the denominator. We need to do something with that. We need to do something with that radical for sure. Okay, so if you recall, if you have a binomial, and you have, let's see, x plus 7 and x minus 7. If you had the same terms and you FOILed it out, you would notice that the middle terms go away and you're left with the end terms. Let's just do that for a demonstration. I'm going to FOIL this out. Okay, I'm going to multiply. So I have x squared plus 7x minus 7x minus 49. Okay, so we have same terms, opposite signs. Our middle terms go away, and we're left with just x squared minus 49. Okay, so let's apply the same principle in the fact that our middle terms will go away over here. Okay, so we've got 1 minus the square root of 2. So the binomial conjugate is the same terms, only with an opposite sign in the middle here. So we're going to multiply both the numerator and the denominator by 1 plus the square root of 2. Okay, and as you'll see, those middle terms will go away, which is where our radicals would be. So let's go ahead and multiply this out. Get our rainbows out here. We're going to multiply 1 times 1 is 1. 1 times the square root of 2 is positive square root of 2, or 1 square root of 2. Negative 2, square root of 2 times 1, negative square root of 2, and negative 2. Okay, because a radical times itself is the radicand, and the signs multiply to be negative. Okay, look at that. Our middle terms canceled out. So now we have 1 minus 2. 1 minus 2, well, that's easy. That's minus 1 in the denominator. Okay, so now since we multiplied the numerator and the denominator by a binomial conjugate, I need to distribute whatever I had up there to begin with the binomial conjugate. So I have 4 times 1 is 4. 4 times the square root of 2 is 4 square root of 2. Okay, so here we go. We're at the end of the line here. I'm going to go ahead and make this look a little prettier because we don't really want 1 in a denominator or a negative 1. So I'm going to go ahead and distribute that out. So I have a negative on the outside and 4 plus 4 square root of 2. Now we cannot combine these terms here because one has a radical, one does not. So if I put that negative on the outside, oh yeah, that's nice. You could also distribute it through, so negative 4 minus 4 square root of 2 is also acceptable, and I think this would be acceptable as well, but we want to simplify things as much as we can. So either this or this would be correct. Okay, so there we go. We got rid of the radicals in the denominator. Hooray!